after we have what is the center of gravity and torque. So here we have the first example. Okay, he's say seesaw consisting of a uniform board of mass m. Mass and that is a seesaw, and the length supports at rest father and daughter. So that means here mg is the center of mass. Okay. The support is under the center of gravity, the board, and the father is a distance d from the, and the daughter is a distance l/2 from the center. Okay. Determine the magnitude of the upward force. The upward force n. Okay. By the support on the board. Okay. First here in here. First of all, that system is at equilibrium. So at equilibrium means that n equals mg, but they are at the opposite direction, and that's going to be applied with the weight of the father with the weight of the daughter. Here he doesn't give us magnitudes, he just gives us symbols like n, m, dg, m, fg. But we are going to determine the magnitude by equations only, and if we had numbers, we are going to apply these numbers in that equations. So we are going to say what n, the system is at equilibrium. At equilibrium, the summation of the forces, and they are simple as y-axis equals the n minus the weight of the seesaw minus the weight of the daughter minus the weight of the father. All equal 0 because they are at equilibrium. As it says, it is at rest. So we are going to say n equal the weight or mg of the board plus the weight of the father plus the weight of the daughter. Okay, that is only the magnitude. So if we have here like numbers, we are going to apply this law directly. Okay, that is the first thing. That is number A. Okay. Number B, determine where the father should set to balance the system at rest. Okay. وقفي. كمل يلا. So here. The father should set to balance the system. So here, to balance the system, that means if the system is not at balance, there is a rotation that is going to be, okay, like here or here, according to the direction. So here, to be in balance, we are going to apply the torque that say the mfg torque, m or the weight of the father, multiply the distance, as here we want it to be at equilibrium, equals the weight of the daughter, and d g multiply l/2. Okay, so he wanted the distance, okay, as it says where the father should sit. So he wanted the d, the magnitude of the d. So what we are going to do the G with the G. So D are going to equal the weight of the daughter over the weight of the father, the mass of the father, or the weight of the father. But here we cancel the G, so it's going to be the mass of the daughter over the mass of the father multiplied L/2. Okay. That is the first example. Second example here. Okay, here is the second example of the static equilibrium in rigid objects. Okay. It says a horizontal beam with length of L. Okay. That is a horizontal beam of 8 meters. Okay. And the weight B is 200 m. Okay, is attached to wall by a pin connection. It's far and is supported by cables that make phi of or phi equal 53.08. So here the phi here equals 53.08 degree. Okay. So, and the weight B, second weight equals 600 Newton. Stands at a distance D. The distance D that is for the weight B from the tension is here. It equals 2 meters. Okay. So the requirements here, what it wants for us. Requirements: find the tension in the cap, the T, and the magnitude of the direction exerted by the wall beam. Like you want us to know the magnitude of the T and the seat. Okay. So first, to make the solution easier for us, we should like set all the equation or the equilibrium equations that we are going to need in that system. Like, if I wanted to make a resolution of forces here first, here, this is the y-axis, that is the x-axis. Okay, and to make a resolution of the t, so we are going to say here is the t sine alpha, sine phi. Okay, is t cosine alpha. Okay, and it's the same here. So we are going to make the summation of all the forces in the y-axis and the x-axis. Let's take the y-axis first. The force in the y-axis equal the T, the tension, sine alpha, minus W, or the weight B, minus weight, or the second weight P. Okay, plus here I have a second force of R. So here is R cosine, R sine theta. That is the y-axis, and here is R cosine theta. So plus because they are at the same direction are going to be plus R sine theta. That is the first equation. Here, number 1. Okay, to make the solution easier. Okay, and if axis or if as a x-axis equal the t cosine alpha minus r cosine alpha, as they are end of the direction, r cosine theta equals 0. Equals 0. Okay, because they are at equilibrium. Okay. Okay. Here, after we have arranged all the equations that we need, and that is the magnitude of the WB and the WB. Okay, that you have arranged. Okay. So we're going to see. He wants us to determine the magnitude of the T. So we're going to apply here the torque, okay, because that is the center of gravity for the O system. Okay, so the torque of this system is going to be, we're going to see, let's see, network equal the so t sine 53.08 multiply the length multiply L is 8. Okay. So that is t sine. So the minus the weight B that equals to 200 B multiply 4. Okay. Minus 600 multiply 2 equals 0. Okay, so the t sine 53.08 multiply 8 equals to 200 multiply 4 is 800 plus 600 multiply 2 equals to 2000. Okay, so here so should we explain t sine 53.08 multiply 8 equals to 2000. So tension force is going to equal 2000 over sine 53.08 multiply 8. We are going to determine it 12.705. That is the magnitude of that tension force. Then T equal here, like we okay, that is the first thing that he wants. Okay, the second requirement is to determine the direction of the arrow. Like here is the theta. Want to determine the theta. So we had said. So the second requirement is the theta. So we're going to apply the law of M that equals R sine theta over R cosine theta equals to tan theta. Okay. So tan theta equals. Okay. So tan theta is going to equal to, as we had determined from the equation, the equilibrium that the t sine theta plus r cosine. So here if y, like we said, the first was going to equal t sine alpha, okay, plus r sine theta minus 800, okay, equals 0. And the in the x-axis here cosine theta minus t cosine alpha equals 0. So here tan theta. So it is going to equal to 2.9. So if we mean tan theta power negative 1 equals to 70.9. So that's it. That is the direction of the. Then that was the two examples of the rigid objects in static equilibrium. Okay, and thank you.